This is in lieu of working over Thanksgiving, so lock in. Yesterday we started 4-4. We were talking about how the different properties of polynomials exist just because it's a polynomial. For instance, if you have a polynomial of degree n, then you have up to n solutions that you could find, or x-intercepts. The new part here is the last two bullet points. And that is that if I tell you that a polynomial has a 0 of a plus bi, then you need to be able to say, okay, then it also has the 0 a minus bi. Same concept, but with radicals. If I tell you a polynomial has a 0 of any radical, then you need to be able to say that it also has the opposite sign radical as a 0 as well. Okay? So the takeaway on that slide is summarizing the whole point of the fundamental theorem of algebra. Then we went to one example right here. Hold on. We did not do this one.
That worked.
Now it's going to crash. No, maybe not. All right.
Whoa. You should have it.
Okay. We did this example right here, where it asks us to just find a generic polynomial with the following zeros. So I listed the zeros, and then underneath it I listed their corresponding factors. And then you just put it together in function notation, and you create the polynomial. You do have to multiply everything out, which is what we did yesterday. The only tricky part, or not tricky, but the extra part, is we don't know if there's some numeric GCF in the very front. There could be a 2, a -1, a +3, there could be a 1/2. I'm talking about right here. We don't know that. So if you're being asked to find a polynomial with these zeros, you need to account for the possibility of any GCF that got pulled to the front. So we just said, let's keep it simple and say that there's a 1 there. Let's don't try and be fancy and say, oh, there's a 2, there's a 3. So we just said, if that GCF in the front is just merely a 1, then the polynomial, and then you get to work with just the factors. And so what we did was we multiplied the difference of squares, and then we cleaned it up because of the I squared, changes the sign, and then you do have to multiply that binomial and binomial, and you get the full polynomial. And that was all we got to with that problem. Where am I? There I am.
Oh.
All right, so the next one is the exact same type of problem. So here's where you would get partial credit for at least being able to show me this, you know? Now, in my math lab, they expect you to get here. But I would give partial credit, okay, they definitely have the factors correct, but they multiplied wrong or they simplified wrong, so their answer's wrong, but I would give partial credit, okay? So let's come down to this next example and let's do this one. Find a poly A, meaning, you know, we're just going to pretend like that number in the front is just a 1 so that it's simple. Find a polynomial of degree 5 that has -1 as a 0 with a multiplicity of 3, 4 as a 0, of multiplicity 1, and 0 as a 0 of multiplicity 1. When you're reading this, I would make a list. I would make a list with your zeros, and then a list with the functions that correspond with those zeros. Because then you can actually work in a procedural manner to get your factors. All right, so what's the first 0 it tells me? -1. Well, if that's my zero, then what's my I said functions. That didn't stop me. That was supposed to say factors. There we go. Alright, if -1 is my zeros, subtract or add it to the left, whichever one you need to do, and then tell me what the factor would be. X plus 1. What was the multiplicity of that zero? It says with a multiplicity of 3. So I'm going to put underneath it multiplicity of 3. So what do I need to adjust over there on my factor? It means that there was a cubed here. All right, next zero. What did it say next? 4. What multiplicity?
1.
So do I need to do anything? No. All right, so what's that factor? X minus 4. What's the last multiplicity? 0, right?
So it'd just be X.
And what multiplicity?
You have a sticky stone silk.
Do y'all understand how I got those factors? Now, that is the foundation of your answer. Now it's put it in a polynomial and multiply it out. Okay? I would probably multiply it out strategically. So first, let's just say, let's let a sub n equal 1, because we're going to keep it simple. We're going to give it a name. We'll call it f of x. And because we're letting a sub n be 1, we don't have to put an a sub n there in the front. So we have the x plus 1 cubed times x minus 4 times x. Okay, so now what you're going to do is clean this up. Let's think smarter, not harder here. This is just one term into 2 terms, so this would be easy to condense, right?
X squared minus 4.
It would be x squared minus 4. This is raised to the third power, 4x, thank you. This is raised to the third power. We cannot evaluate it to the third power, so I'm going to split it apart into a second power and then the 1 left over. You see what I did there? Because I can only evaluate 2 at a time. And then now I'm going to change that last one to this. Now you could technically work on these 2 things at the same time. You have a binomial squared here, and then you have a binomial times a binomial. So you could do those in the same next step, or you could, work one over here, work one over there, and then plug them back in. But just remember that in between them is multiplication. So we still have a lot going on. And did we go all the way? We did go all the way. Yeah, we're going to go all the way with this. All right, so x plus 1 squared means x plus 1 times x plus 1, right? Okay, there is a pattern when you're squaring a binomial. The pattern is, video, okay. The pattern is, I'll just show you with this one. This is a binomial squared. You're going to get 3 terms when you multiply it out completely. The first term squared, so first squared. The 2 terms multiplied together, doubled. And then the last term squared. That's the pattern. It's the first term gets squared, the 2 get multiplied together, and then you double it, and then the last term gets squared. I don't know if I want you to try to memorize that pattern or to just work it out like this. It's up to you, and then do first, outer, inner, last. But you should see first, when you do outer and inner, that's where the double comes in. And last. So that's a shortcut. That only works when it's a binomial squared, which, as you can see, we're doing a lot in this section. So it might not be a bad idea to practice it. So I'm going to come back over here. So that binomial squared is going to be x squared plus 2x plus 1. And then now I've got to do this x plus 1 times x squared minus 4x. So first, outer, inner, last it, right? And combine any like terms. So first, outer would be minus 4x squared. Inner would be plus x squared. So that would be minus 3x squared. Last would be minus 4x. As much as I know you would love to be like, okay, I'm done, I got all that. You have to multiply this now. That is a trinomial times a trinomial, which means first, outer, inner, last does not work. Have I lost you? Have I lost you? Oh, okay. First, outer, inner, last does not work here. Remember that method that I taught you in the beginning called split repeat, beat repeat? That works. Or you could sit here and like hold your non-writing hand on the first term and then just visually in your mind multiply by all of that and write it. Then go to the next term, multiply it by all of that, write it. Like, it's up to you. Some people do the box method. I like the split repeat, which means I'm going to split this into 3 terms. X squared, beep, plus 2x, beep, plus 1, plus 1. Oh my goodness, right. Then I'm going to repeat that. You know, the only downfall to this is that, can you give me my water? The only downfall to this is that the actual new stuff was not bad. It's multiplying it, which is stuff you already know how to do. It's just multiplying it to get to the final answer that's the bad part. That's what drives people nuts. Have y'all tried it? Multiplied it out? I know, I'm sorry. Yeah. Top that left drawer, and then grab that blue sticky note. There you go. Anyone need any other?
No, it's gonna split repeat. I'm just gonna write the answer.
Oh, that's just good. Oh, good. That's just good.
When you multiply it out completely and then clean up your terms, see if you can get here. You should come to that.
Those funds.
Please don't let the multiplying out bog you down. Make sure you understand what was the actual new concept, which is if I tell you these polynomial or these are the zeros of a polynomial, then you can write them as the factors. Okay. A way to check yourself, if you're one of those like me that likes to know if it's right before you keep going on, you could go to your graphing calculator and you could type your first answer in Y1 and you can type your final answer in Y2, and when you go to graph it, they should overlap. It should be the same graph. So if you type those in and then you go to the graph and you see two graphs, like two totally different, something's wrong. And odds are it's the multiplying because it's just so tedious and there's so many things to multiply. If I had come to a 6 right here, how would I know it's wrong?
Gaps.
Telling you the answer should have no degree higher than 5. It's a degree 5 polynomial. So that is telling you as a checkpoint, like check your final answer, it should match this degree. Okay? Okay. Besides the multiplying, what do you think? I get it. The multiplying's annoying. But the other stuff, not bad. You get it? Stay with me, right? As far as the test goes, there would not be like a ton of these because that takes time. I need to know, can you do this?
Yes.
You should be able to do the multiplying, but you would get partial credit for being able to do the new part. All right, go to this slide. The purpose of this slide is to say sometimes when you have a polynomial, depending on where the polynomial is on the graph, it may not cross the x-axis. If it does not cross the x-axis, that means it does not have any actual x-intercepts, which means it has no real solutions. Instead, it has imaginary. Right? We've talked about this before. If the graph is never crossing the x-axis, then there's no solutions. Not real numbers anyways. Instead, there's imaginary solutions. So even though it may have actual real numbers in the polynomial, like x squared minus 2x plus 2, that's a real polynomial, those are real numbers. But if I go to graph it and solve it, it's hovering up above the x-axis, opening up, which means it's never going to cross it. So if I actually did solve it, I come to two imaginary solutions. Which brings us to, okay, what about if it's an actual real number, but it's irrational? Meaning it cannot be written as a fraction. So if there is a radical 0, then there is also its conjugate. So if a plus c root b is a 0, then a minus c root b is also a 0. Okay, so I say all that, and you're probably like, I have no clue what you're talking about. All right, so come right here.
Oh, I was not done right.
Oh, okay. Go back.
Okay.
Look at this example. Suppose that a polynomial degree 6 has the following rational coefficients, or with rational coefficients, has these as zeros. It says -2 plus 5i, -2i, and 1 minus square root 3 are 3 of its zeros. Find the other zeros. Did it ask me to find the polynomial? No, we're not doing what we did earlier when we have to write them and multiply it out. We're just saying, if you tell me that -2 plus 5i is a 0, then what am I supposed to say right behind that?
-2 minus 5i is 0.
Bam. That's it. That's all this
And
is
then
asking.
1 minus the square root of 3 and 1 plus square root of 3, right?
Yes.
You're so smart.
I'm going to help you organize your thoughts here. Instead of coming over here and scribbling it down, let's make a list of what they gave me, and then let's make a list of what we can imply, the others. The list they gave me was -2 plus 5i, -2i, and 1 minus root 3. That's exactly what they gave me. So if those are part of the zeros, then what we've learned is that because this has an I, and a radical, there's another one they failed to mention. What is the conjugate of -2 plus 5i? -2 minus 5i. You only change the sign of the imaginary part. What is the conjugate of -2i? 2i. You also, for conjugate of radicals, you only change the sign of the radical. What's the conjugate of 1 minus root 3? 1 plus root 3. And then the question said that the polynomial has what degree? Well, how many zeros did I just list?
6.
So are there any more possible?
No.
No. So let's make a note. Since it has degree 6, there are at most, meaning no more than, 6 roots. Or you can say zeros, or you can say solutions. It's up to you. I like to use the word roots because you're going to see the word roots, and a lot of people forget what a root is. Everybody knows what an x-intercept is, what a solution is. Root and zero are the words that some people are like, I have no clue what it's asking. So since it has degree 6, there are at most 6 roots. We have 6 lifted here, so there are no more. There's no more possibilities. Remember we said that the degree of the polynomial gives you a calibration of how many answers you come to, or roots. They're telling you it has degree 6, and they said, hey, by the way, it has these 3 roots. Well, because they're imaginary and radical, there's more they didn't discuss, and once we listed them, we've covered 6 zeros now, so we're done. Now, what if we had only covered 5? You would just say there is possibly 1 more zero. It's not asking us to actually find it. We have no way of finding it. It's just saying, can you tell me, are there any more? And can you discuss if there could be more that you can't find, but you could at least say, well, I only found 5, so there's possibly 1 more. You know what I mean? Okay, now this next example is exactly what we just did from the last slide, the one where we had to multiply. You are taking the zeros it gives you, you're writing them as factors, you're putting it into a polynomial, and they want you to multiply it out. Okay, The new part here is you have to list what was given, list what is hidden, and before you proceed. Okay? Find the polynomial function. So make sure you understand when the difference between find the other zeros, find the polynomial. You know what I mean? Sometimes you are just finding the other zeros. Sometimes you are actually multiplying it out. There's a difference. So know the difference of when to do which. It says of lowest degree, which just means don't get crazy. Don't throw extra stuff in there. It means keep it simple. It has negative root 3 and 1 plus I as just two of its zeros that they're going to give us to start with. So y'all know me, I like to take notes. What am I given? What can I imply? And before I proceed. Just like. So what did they give me in the problem? Negative root 3 and 1 plus I. Remember, the only ones that have a secret hidden partner are the ones with an I or a radical. Okay, if they had said just negative 3, then you do nothing with it. Don't jump over here and say, oh, but positive. That's not the case, okay? Has to have a radical or an I. Okay, this has a radical. So what's the conjugate root? Square root 3. And this has an I, so what's the conjugate root?
1 minus I.
Very good.
Yes.
Stop. Sorry. Now, this one is, remember we said, is actually asking us to go to the polynomial. This is a little new, so let me help you. Remember when I showed you how to get the factors? I said if you'll just say to yourself like x equals negative root 3, and then you move everything to one side, then you can see the factor. So this is tough to see right here. X equals negative root 3. If I want the factor, I would add that to the left, and I get x plus root 3, right? So what would the other one come from? What would this one come from? X minus root 3. Let's repeat the same thing with the I stuff. So if I said, hey, 1 plus I is the 0, now subtract everything over, or add everything, it depends on what the signs are. So I'd subtract the 1, subtract the I, it looks weird, but go with it. So that's the factor. It looks weird, it's because none of the terms are alike. Yeah, I know. And then x minus, what was it? X equals 1 minus I. If I bring all that over, what do I get? Yep. You should notice that the only differences are the signs of the thing I told you to look for. The only differences are the signs of the I's or the radicals. Okay? Don't get lost in that. Okay, so what you've just done is you've just found the factors. Now we gotta remember from that last slide. Now we gotta put it in polynomial form, and we're gonna have to multiply it out. Like we've been saying, let's just let that leading coefficient be a 1. Now we're going to put it in polynomial form. F of x equals. You want to group them by the ones that were conjugates of each other. Like, let's don't mix the radical with the i's. Let's put the two radicals together. Let's put the i's together. So I've got x plus root 3 x minus root 3, x minus 1 minus I, x plus, no, minus 1 plus I. And just for the people that are watching the video, like this came from here. This came from here. This came from here. And this came from there. Right? Don't you wish we could say, okay, that's the answer, now move on, right? Have you seen a single one of our polynomials look like that?
Can we put that in the calculator, or do we actually have to solve that?
We can't put that in the calculator.
It'll give you a decimal. And it wouldn't work.
We can't
Rather
put
than
X.
give a decimal. I don't know how to do that. That's too much.
Well,
See, I'm just gonna
this
sit
is,
back and watch.
Yeah, I can't do it.
yes you can. Don't say can't. Don't say can't. This is why you're in here.
I hit legs yesterday and I can't do it.
Good thing your legs have nothing to do with this. You can do this. You're in here for a reason, okay?
Yeah,
You're in college level math. You can do this. I believe in you. Okay?
Thanks.
I'm going to walk you through it. Okay?
Okay, I'm just
Remember to think smarter, not harder. Okay? Don't get lost in the radical,
smarter.
the eyes. I've already taught you to look for patterns or things that help you. What do you guys notice about this? What? Difference of squares. Do you remember the shortcut I told you yesterday? If not, let me remind you. There is a shortcut. I'll go with this one. Let's do x plus 2, x minus 2. When you are multiplying a difference of squares, the middle term cancels every time. So there's no need to find it. It's going to cancel. All you have to focus on is the first and the last terms. Okay? And the way you get the first and the last terms is by multiplying the first terms and the last terms. And that's it. So like this right here, I can do it in my head. That's going to be x squared minus 4. Because I know it's a difference of squares. I know the middle term is going to cancel. It's going to be x squared minus 4. Okay? So let's come back over here. This is a difference of squares. And that was by design. This is the way. This is the way. I feel like Mandalorian. This is the way because it was by design. Because we had to write the conjugates over here. We have created the difference of squares. So we're going to multiply it. First times first, last times last. Right? Yes, I know the square root of 9 is 3, but I don't want to do that in my head and then someone say where did the 3 come from. I'll do it on the next line. Do you also notice this right here is a difference of squares?
No.
Do you see it?
No.
What do you notice is different?
There's 3 terms.
There are 3 terms, but look right here. What's the same? The first 2 terms match. It's the last term that's different signs. You see it now? So you could multiply that out completely if you wanted to. You could do what? Hey Brody, remember when you said we're gonna get like some good stuff done today?
I'm awake. I'm
We're
listening.
doing a lot for like what? 8 people?
Oh, maybe.
There's 11 of us. Get the number right.
Is there 11?
Yes.
So this will be like the class next semester.
Raise your hand if you're not here.
Hey, even better.
I've told you that I've never had this class at remember there was 32,
Are you taking
33.
the class?
There was 33 the first week of school.
Do you have
It was
pre-calc
awful, and
accessory?
I begged them to switch it into two, break it into two sections, but they couldn't do it because of y'all's smart
Dr.
base
Roll will be like, just
and
come tell me
your
if you're not.
shell, whatever, something to do with
He
shells,
literally says it every day.
offering. Yeah, I'm like, why does he get cracked?
You just want to know.
You know why? He's
Yeah.
an athletic director. Man, he's a man.
I'm sorry.
I said it.
Sorry.
I think Parker kind of agrees.
Yeah, it's true. It's true.
Parker's kind of like isolated back there.
He likes the standing desk. You're making me uncomfortable.
Pierce, you want to keep your shoulders?
No,
1,
no,
2,
no.
3, 4.
Oh my. You do that to Brooklyn.
No.
That's how he's on Brooklyn.
That's surely not. Surely. I'm going to talk to her. Alright, so look at these parentheses and look right here. Look right here. The highlighted part matches. It's the last part that's different. Remember we said multiplying a difference of squares. All you have to do is the first part and the last part. Well, the first part is x minus 1, right? So it's going to multiply by x minus 1. So watch how I do this. I draw really big parentheses because I'm fixing to draw another set to say, okay, that x minus 1 is going to get multiplied with another one. I haven't done it yet, though. I'm just marking it. And then I'd have minus I squared. Yes?
I got lost with the difference in squares. Are we looking at like how the I is the difference part?
Mhm.
Should appreciate
Okay,
it.
because I was like, isn't that supposed to be minus and that's what I got lost.
It
I thought
is.
we were looking at
What?
yeah, but I thought we were looking at the x minus 1.
No, I wanted you to see that, think of that block as your first, and it matches. If the only difference here would be that sign with the I. Notice that I drew this parenthesis really big, and then this one's really big to let me know what's going on here. Notice inside it, all I have is that block times itself, and then minus I squared. Okay, now let's clean this up. What's the square root of 9? That would be 3. Right? Three? No, don't. It's already there. It came from over here. Remember? Okay, right here. You can do this two ways. You could go ahead and multiply the x minus 1 squared. Remember, this was when it was perfect squares. Now this says x plus 1, so be careful. But remember, it's you square the first term, multiply the two together, and double it, and then you square the last term. That's the shortcut. So square the first term, multiply the two together, so negative 1x, and then double it. So it'd be negative 2x, right? And then square the last term. Look to see how I got that. Y'all, I think you need to move.
He was doing good.
I don't think you can, that's fine, I have more.
It's just like a long.
Don't erase that.
This one, it'd be negative 1 times negative 1. So, yeah. By the way, that should always be positive when you're doing the perfect squares. Because it's
The
always,
last one should always
Yeah.
be on.
Yeah. because if you think about it, it's something times itself. The only way to get a negative is when they have different signs. And we're multiplying something by itself, so they're going to have the same sign every time. Alright, so that was just that shortcut. So we're going to come back here, and we're going to put that in here. We got x squared. What do we say? Minus 2x plus 1. Now, what is this mess right here?
Follow the perfect square. I can't see.
Move.
She picked up what I put
Plenty
there.
of other
There's
seats,
plenty
just
of other
move.
seats.
You never
Alright.
told Addison or Annabelle to move.
Well, they've
Because
never
they don't complain about not
told
about
me
not
that
being
they
able to
can't
see.
see. Actually,
Oh,
well, Addison
They
does.
say it a lot.
Yeah.
And then Addison just like cuddles up with a pillow and takes a nap.
She does.
Get off my seat. I would leave that on the recording and let Addison hear that.
I am.
Hi, Addison.
T-Hall.
Hope you're not asleep. T-Hall, eliminate Pierce.
All right.
Exterminate.
All right. I moved. Are you writing it down?
Yeah, I'm getting my pen to write it down.
You're gonna be mad when I tell you this. Football just now got to eat, and they've been out there for an hour, and they couldn't. They didn't.
At least they're allowed to eat.
They haven't even left yet.
Well, they weren't leaving until like 2.
They're not leaving until 2:15. Their food is supposed to get
How
ready
you
at
know?
12.
They literally had an hour to get ready. That's what they
Who do you think told me?
New boyfriend. That Chloe knows it.
Pierce, can you do your notes, please?
Am I done?
No.
I know. Are you done? Yeah. I'm not done. You gotta keep going. So I know you can't stand this, but you gotta get over it. Build bridge, get over it. It's part of it. College level. Alright. What is this right here on the end though?
I know.
Like I would just, that would be
More.
a 2, right? Okay. So
I can't do it.
now you do have a binomial times a trinomial, which means it's not as bad as that last problem. You can't do first out or inner last. You're going to have to do beat repeat, split repeat. If you need a refresher on that, here it is. The first set of parentheses, in my mind, I visually separate the terms and I spread them out. So I've got x squared. I've got x squared beep, minus 3. Is that you, Pierce? Beep.
What? What Pierce do?
In the B, I repeat the second set of parentheses.
Oh.
Now I have the first binomial separated to allow me to distribute just one term into each of the trinomials. And I would encourage you to finish that and then check and see if you get this as your answer. So I'm writing the answer, so don't write the answer. Like take the next line to multiply it all out. And then combine terms and see if you get this as the answer.
Yeah, I got it.
That's Cap.
Yeah, this is all Pierce does is like take jotted notes on this, and then he'll go back at like 2 a.m. the day before the test and watch all the videos and take detailed notes and just remember it all.
So do you have any
That's
conceptual
extremely
knowledge?
accurate. What'd you say?
Do you have any conceptual knowledge, or is it all short-term memory?
What does conceptual mean?
You
Wait, why is
understand
that negative?
I usually just understand it. I don't know. It's
Why is it negative x squared? Wouldn't it be?
I think I did something wrong.
Let's go to my math lab. Click.
Oh wait, I haven't added them. Is that them combined?
That's the final answer.
Oh.
Yeah.
Looks about like what I got. It was
Okay. This is one of my absolute favorite parts because this is one of those types of problems. I'm going to show you how to do it, and once you do it, you're going to look back at it and you're going to be like, I can't believe I just did that. Like it's a boost of confidence. Okay. Okay. I love these problems because
Chloe, what is this?
you can throw it at someone and they'll be like, I have no clue what you're doing. And then you just go through the steps and nail the answer, and it just makes you feel really smart about yourself. We are solving polynomials. Y'all with me? We're solving. Landon and Sullivan, check your email. Miss Boo sent you something.
Oh, why do you have big questions?
It has toothpaste on it, so
Oh, really?
yeah.
Okay. I didn't give you mine. I just
Okay,
submitted
just
it.
submit it on top.
I did. Okay.
Oh, is this gonna be a daily thing?
All right. Shh. Y'all, please
Okay.
focus. Okay. Here is the polynomial. I want you to go back to. Don't write this. I want you to go back to like let's do this. Let's do something simple. Go back to this. This was in the last chapter we did, and you had to solve it, right?
Right.
You solved this by square roots because there was only the x squared term. You add the 4, you square root, and you came to 2 answers, right? Okay. We are doing this, but with this. So we're leveling up. You with me? Now, as part of leveling up, obviously there's more work involved. We have a degree 4 polynomial, which means we should come to how many possible answers? 4 possible answers. It's really important that you understand that, okay? Notice they don't give me a single thing to start with. That's the difference here. If you think back to 4, 3, 4. I think it was 4, 3. Remember when they gave us an answer and they asked us to see if it would divide and if it is a factor? That is exactly what you're doing here. The difference is they don't give you anything to start with. Remember the problem yesterday when I said just pick a number? And people threw numbers out and I was really hoping for the number 1 because it worked. Same thing here. But math is not just pick a number, right? There's something called the rational root theorem or the rational zeros theorem. I call it the rational root theorem. The rational root theorem says there is a pattern when you solve polynomial functions. The pattern is there's a relationship in the actual answers compared to the A and C coefficients. You staying with me? A is the one in the very front. C is the constant at the very end, right? There's a pattern in the answers. Do you remember what rational means? Can be written as a fraction, as a ratio. It can be written as a fraction. There is a rational root theorem which says if you will list all the fractions created by taking P and Q, and what we mean by P and Q is the last number and the first number, and you list your fractions as positive, negative, P over Q, you get the list of all the possible rational exponents. Okay, so what does that mean? I just said that and you're probably like, I have no clue what she's talking about. It says find the rational zeros and then any other zeros, which means solve it, right? We're going to solve this without using our graphing calculator. Did they give me anything to start with? No. Mind your P's and Q's. Y'all remember that phrase growing up? It meant like have good manners. Yes? Yeah, sorry. It meant have good manners, mind your P's and Q's. I want you to think of mind your P's and Q's. It is backwards. P is all the way at the end. Q is the leading coefficient every time. It is backwards. It's not in alphabetical order. Now what you're going to do is you're going to ask yourself, what are all the factors of P? Well, P is -4. Come over here. Don't write big, y'all. P. What are all the factors of P? Well, you got 1. Will 2 go? Will 4 go? Anything else? Notice I put plus or minus in front of them because even though +1 goes, so does -1. Even when positive 2 goes, so does negative 2. So you have to consider plus or minus. Now you repeat with Q. Q is the number 3. You're going to appreciate when it's those prime numbers. Are you staying with me? I swear you're going to be so confused.
I'm nervous.
What are the factors of 3? Always count. Well, 1 works, and 3, right? We have our list of factors of P, factors of Q. Now we need to make them into fractions. Okay, this is, a lot of people don't like fractions, but this is not that bad. You're going to set it up as P over Q. All of them. So there's a lot of possibilities. Here's what I do. I take my non-writing hand and I hold it over the first P. And then I take my writing hand and I visualize 1 over 1 is what? 1 over 1. 1. 1 over 3. Write it. Then I move my non-writing hand to the next one. 2 over 1. 2 over 3. Write it. Then I go to the next one. 4 over 1. 4 over 3. Write it. I told you you're going to be lost if you're not watching. Now, before we dive in, let me show you what we just did. Because I want you to know the big picture here. What you've just done is you have just named all of the possible, meaning they don't all work. It's just the ones that do work are in there. You've just created the list of the possible solutions, and it came from the relationship of P and Q, or as we're used to calling it, C and A. This pattern is called the rational root theorem. It means in every single polynomial, when you solve it all the way, the real numbers, notice none of them have I, none of them have radicals. It's always the real. Your real numbers are in this list. Okay? So remember when yesterday I said just pick a number, plug it in? Now I'm going to tell you, pick a number, plug it in, but you have a list of numbers to pick from. And at least one of them has to work. Now, I tend to pick smarter, not harder. I tend to go with the nice numbers before I hit the fractions, right? And you do have your graphing calculator, so you could type it in y equals and go to the table and then find one of those numbers in the table. What am I looking for to know if it works? Do you remember? Equals 0. I'm looking for it to equal 0. Remember we said if you plug the number in and it gives you 0, it is a 0, which means it's a solution, which means we can run with it through synthetic division. So, try 1. You're going to go to the polynomial. You're going to plug 1 in. And then confirm if you get 0. Plug 1 in and see if you get 0. Huh? 1 does not work. Try -1.
No, she needs her calculator. It doesn't work.
Oh.
-1 does work.
-1 should work.
Then why'd you tell me?
Because I need you to know when it doesn't work.
Miss Holcombe, can you turn the brightness on?
Second arrow up. Second arrow up. Over and over. When you plug 1 in, you should not get 0, which means don't use 1. It didn't work. When you plug -1 in, you should get 0. What?
copy and paste on a calculator?
You can. 2 ways. You can arrow up.
But you can't put a negative in front of what's in the
Yes, you can. I got you. You can arrow up, select what you want to copy, hit enter. It'll bring it down. That's one way. I like to do the other, which is second enter. It will repeat the last thing you typed. If you need to squeeze a negative in,
Even if you clear?
Yes.
if you need to squeeze a negative in, you hit second enter.
Oh my
It's
god.
just about the same.
So let's just pretend like we're going to squeeze a
Me too.
negative in. You
You're
arrow over right
These were pretty
before,
cool.
and you hit second.
Where'd you go?
INS means insert, and it'll. I hit the second.
You hit delete.
I hit delete. Hold on.
My toothpaste fell
All
out.
right, ready? Second insert, and now it's going to say, "What do you want to insert?" And you can type that negative, and it'll bump everything behind it. Yeah.
I swallowed like something.
Am I gonna be all right?
the insert button?
It is.
What's the
I
delete?
love your not too slow.
Huh?
It says I'm not too. I'll show you what.
Wait, oh, I have to go to where I want to insert.
Yeah.
The 0 has to be in the Y, right?
Yes.
Do not swallow. If you swallow, consider going.
To the doctor.
Holcombe. Calling poison control. That's Holcombe.
I don't think there's enough on there that you need to worry about it. I don't think there's enough on there to.
Which one of
to
you was
matter.
it?
You swallowed it? Did you swallow it?
No.
Did you swallow yours, Hayden? The toothpaste?
My toothpaste is
No.
no the toothpaste.
Where'd y'all just spit it out?
Yes, I told you. It's right there.
I didn't know that. Yeah, I looked at y'all and asked y'all if y'all swallowed it. Y'all said yes.
So I'm waiting on everyone to type it. Did you get negative
I don't know
1?
if I did.
Yes.
0?
I
Okay,
feel
okay. What's the matter?
I'm getting my blood work today. After school. Does that mean there's
Mine
like
disappeared.
Okay,
heroin? Bro, you're dead.
we found f of negative 1 to give us 0, which means let's run with it. Negative 1 worked. Now, here's where we do that synthetic division that you've already learned, okay? So, if negative 1 is already the 0, please don't change the sign of it. That is the 0. Remember, you only change the sign when it's that factor, if it's the factor. So, negative 1 works. So, we're going to set up our synthetic division box. Remember, check for gaps. There is a gap at x squared.
Right.
So check that. You got 3, negative 11, 0, 10 of, I didn't space mine correctly. Negative 11, 0, 10, and negative 4. Alright, if you remember the synthetic division, bring the arrow down and then start multiplying.
I hate these calculators. What? I did something wrong.
Now remember, when you plugged that negative 1 in and you got 0, that is already letting you know that you should have a remainder of 0.
I would say don't mind.
So we're just plugging it into synthetic division.
why do you have the whole pack?
No, well, this is something new, like we're gonna keep going. The whole question here was, hey, I need you to solve it. Well, it was a degree 4, which means this is what degree?
Oh, degree.
This would be degree 3, right? Or x, you could say arrow like x cubed, and I'm just saying like it's a degree 3. We need it to be degree 2 because we know how to solve quadratics from the last chapter. This is a cubic. This means we need to keep going. Go back. We gotta do another one. Go back to your polynomial. Go back to your polynomial. Pick another number from your list. Plug it in until you get 0. I'm going to tell you it's a fraction.
Oh, so you can't look at
You
the table?
can look at the table if you change the table setup.
I have to restart my calculations.
Yes. Oh, I think we have a degree 5 at one point.
Wait, but so we were trying to figure out the original equation.
Yeah, in
not
the
new
original.
equation.
Yeah, original.
So do we need to finish this here?
You're gonna see, this is a domino effect now. It's,
But do we like finish this one?
Not
What's
yet.
up?
Yeah, do you finish this off when you add the?
yeah, I need y'all to find another 0. Did you find 2/3 to work?
Oh yeah.
Hey, hint.
She wants
Yes,
to
ma'am.
use 2/3.
Consistent with our stuff. So we just checked 2/3 and we got 0, which means we're gonna run with 2/3. Notice my synthetic division box is a little smaller because I am now breaking down the previous coefficients. That was a trinomial. I bring them down here. And now I'm doing synthetic division again. Now, you do have to multiply by 2/3. I would not rely on the calculator. I would tell yourself, I am doubling, then dividing by 3. That's what times 2/3 does, right? So you're just doubling, then divide by 3. That's the equivalent of times 2/3. So, 2/3 times 3, so double the 3 is 6, divide by 3 is 2. Add. Repeat. Double negative 24.
Uh-huh.
The double, I'm sorry. Double negative 12. Negative 24. Divide by 3. Negative 8. Add. Double 6.
Well,
Divide by 3.
4.
We already knew you should come to 0 because we found. It started as a degree 4. We broke it into a degree 3. So this is a degree 2. So I'm going to write it. I've got 3x squared minus 12x plus 6. You have to solve that, but you should notice, remember, think smarter, not harder. What do every single one of those terms have?
3.
They have a GCF of 3, so divide the entire thing by 3. So I'm just going to draw an arrow to say, okay, I've noticed there's a 3 factor in there. I'm going to divide everything by 3. And now I have x squared minus 4x plus 2. That is a quadratic that will not factor. You use what method to solve quadratics that won't factor? Quadratic formula. I told you. Welcome to college.
Does the 3 go away?
Oh yeah, it's gone because this is GCF and it has no x.
Okay.
Yeah, it's just a number. Because when you divide on the right side, you would get 0 anyways. So you are going to finish this. I'm pulling it over here because I've run out of room. You would finish this by solving by the quadratic formula.
And that was your answer?
Well, the question said, what are the zeros and what are the linear factors? So let me show you, you can take a picture of it. Let me show you what it would look like. Hold on. This was last year. 0. All right. So right here is where we said, okay, let's finish with the quadratic formula. And then we said what our solutions would be.
You're not in it.
This is where we finished with the quadratic formula. Then we said, okay, here's our solutions. Then you had to write them as factors. And the good news is that my math lab will let you stop here. They don't expect you to multiply all that out.
This is basically algebra with just more algebra.
Algebra on top of algebra.
Algebra with